Welcome to the physics class, and we have a catapulted stone magnitude object. Magnitude initial is 20 meter per second. That's launching speed, and launching angle 40 degrees. Magnitude of the horizontal at time is equals to 1.10 seconds. And what we do, we have to keep on the data. We have vertical speed. That's going to be initial speed multiplied by cos theta, and then that is horizontal. Then vertical is going to be initial times sine theta. And then when we have initial speed, that's 20.0 meter per second, and then we have time there, that's for horizontal and vertical, the same time. So the object is a two-dimension, so it moves in both directions at the same time. So t is 1.10. so change in x, that's the distance, will be the initial speed multiplied by time multiplied by cos 40 degrees. And then we have to substitute the value, so that's going to be initial speed 20.0 meter per second multiplied by time, that's 1.10 second, and that's cos 40 degrees. And then we can use a calculator to find the answer. That's 20 times 1.10 multiplied by cos 40 to give us 16.85. So that's going to be 16.985. That's good at 9. So our unit is meter. We do the same thing for the vertical motion. So change in y, change in vertical position at time is 1.10. That's v multiplied by change in time sine theta, initial angle. So we have that's minus half g change in time squared, and then downwards it's negative, and then that's 20.0 meter per second multiplied by 1.10 second, and then sine 40 degrees minus let's take down as positive, minus half, and then that's 9.8 meter over second squared multiplied by time, which is 1.10 squared. And then simplifying once again, we have two terms. The first term there, that's 20 times 1.10 times sine 40 degrees. Let's compare 20 times 1.1 multiplied by sine 40 gives us 14.14. So it's going to be 14.14. 133. We don't round off before the final answer. So the second term, which is half, 9.8. So that's going to be 1.10 squared multiplied by 1.1 multiplied by 20. Multiplied by 9.8 divided by 2. That's going to give us 5.929 meter. So that's going to be 8 let's say 14.14 multiplied by 5.9 gives us 8.21 meters. So horizontal for the next question, so our time is 1.10. So 1.10, so we just punch in the equation which says change in x is equals to initial velocity multiplied by time multiplied by cos of an angle for two dimension, and then we have initial angle, which is 20.0 meter per second multiplied by 1.80 second multiplied by cos 40 degrees, because we're using the same angle, it's just the time that changed. So multiplying that, 20 times 1.8 multiplied by cos 40 degrees gives us 27.6 meter. Moving on to the next question. So we have change in y, vertical change. So that's initial velocity multiplied by time multiplied by sine of an angle, again minus half. This is g multiplied by change in time squared. So that gives us initial velocity as 20.0 meter per second there, multiplied by time is 1.80 seconds, multiplied by sine 40 degrees minus half our gravitational acceleration, which is 9.8 meter per second squared, and then multiplied by time, which is 1.80 second, and all that squared. And again we do one part of the equation, so that's the first part. So it's 20 times 1.8 times sine 40 degrees gives us 23.14. So that's 23.14 minus we have 1.8 squared multiplied by 9.8 divided by 2 is 15.876. So that's 15.88. And then using a calculator, 13.14 minus 15.88 gives us 7.26. So 7.26 meter. That's our answer. And then we move on to the next question. The next question is going to be at time is equals to 5 seconds. So we can't just put any time there, because we need to know what time the stone or the object hit the ground, because remember it's a projectile, it will eventually hit the ground. So when the time taken when object hits the ground, so that's what we need to know. Does it exceed 5 seconds or it's below that? So to do that, we use the equation which says change in y is equals to velocity of y multiplied by change in time sine theta minus a half, which is g change in t squared, and that gives us a 0. But we can also put the 0 on the original equation there, so it's equals to 0. So we take the right term, which is half g change in t squared is equals to initial velocity change in t sine theta. Okay, so we break the two terms into left and right, so divide both sides by change in t, so that cancels, so that goes there, change in t once. And then we have change in t as 2. So remember it's half multiplied by 2 both sides, so it's 2 multiplied by initial speed multiplied by sine theta. So divide by g. So that means that we have 2 multiplied by initial speed, remember that's 20.0, so it's 20.0 meter per second, multiplied by all over 9.8 meter per second squared, and then multiplied by sine 40 degrees. That gives us equivalence of that's 2 times 20 divided by 9, okay, multiplied by sine 40 divided by 9.8 is 2.62. So it's 2, okay, cancelling the units, okay, s, so divided by s, so it's per second, so seconds, so that's 2.62 seconds. So it takes 2.62 seconds for the object to hit the ground. Now that it took 2.62 seconds to hit the ground, so we need to know the horizontal distance covered, so it's initial velocity times time times cos theta, giving us initial velocity of 20 meter per second, multiplied by 2.62 second multiplied by cos 40 degrees. So that gives us, using a calculator, that's 20 times 2.62 multiplied by cos 40 gives us 40,14. So 40,14 as our final answer. That's the horizontal distance covered. So now looking at the y velocity, we assume that after 2,62 seconds the object stayed on the ground. So I assume it stays on the ground. It stays on the ground, and then we have at t, let's say t is equals to 5.0 seconds. We have change in y as 0, so it didn't move anywhere. So that's our final answer, and that's how we track that. So you don't just punch any time. So that means we need to find a positive value because the object never went underground. So that's it. When coming to time, make sure that if you know what time it hits the ground, if the time is large enough. And yeah, so thank you so much for watching, and this is your tutor Black Adam 5D. This is Black Adam 5D tutor. And don't forget to follow or subscribe. If you have any question, you can leave below. Thank you so much for watching, much appreciated.